Hey everyone, welcome back to my channel. It's Steven here. I hope you are all well. Today we're diving into the Dependency Inversion Principle, one of the 5 solid principles of software design and the last one on this series. If you're struggling with tight coupling in your code and you want to learn how to write loosely coupled code that is flexible for modification and testing, then this video is actually for you. The Dependency Inversion Principle, or DIP, is all about reducing tight coupling between different parts of your code. It says two things, which are high-level modules like your front end shouldn't depend on the low-level modules like your back end for data, but should depend on abstractions like interfaces or contracts. Does this sound fancy? Let's have a quick look at a Python example to make it clearer. So here in our first code, we have a very bad way of implementing the dependency inversion principle. This is a violation of dependency inversion principle because this the backend service is tightly coupled to the front end service, which prevents any modification or will cause error if there is any modification in the backend service on the front end service, because they are tightly coupled together, because this is an immediate implementation of the backend service in the front end. So if we were to fetch data from another source, maybe like here, the fetch data method in the backend service is simulating an API call here. So what if we have a local data source that we want to call the data from in the front end service? That means that's going to be a problem. So this is going to totally change and making the front end component also change as well. So this is violating the dependency inversion principle. So which our code is not flexible for modification, and it's going to be testable with, let's say we want to test with mock data instead of testing with our real data for data protection, for instance. This is going to be a hindrance. So now that you've seen the violation of the dependency inversion principle, let's look at the refactored code of where we're able to implement this the right way. So here, as you can see, we have created some extra classes to abstract the relationship between the front end and the back end. So here we're using the Python ABC abstract method to create an interface or a contract, because here the class iDataService is inheriting the ABC class, and the method fetchData is abstracted. So now this is an interface, like a bridge between the front end and the back end. So the back end is going to also inherit is going to be called through the interface. So here the fetch data is going to return data from the back end. So now with this implementation, we can write another method that is going to be for fetching local data, for instance. Then here we have another class here, which is the mock service. So assuming we want to test our program before we ship it out, here this mock service is also called through the iDataService, which is the interface. So now it's going to return data for testing when you call the fetch data. So here our front end component is going to call test, is going to add data service, the iDataService, which is the interface, as a parameter. So now, first of all, in the constructor, we have to test that this iDataService, the methods are properly implemented. That is why we should raise this value error in case it's not implemented. So that's why it says data service must implement iDataService to catch any errors in case we will forget to implement it accordingly. So now when we call the render method, which is going to be the data service does fetch data. So it's going to print rendering data and it's going to call the data class. So now in the usage, we'll have a real service which is going to we will assign to the backend service. So we want a front end with real service. So it's going to call the front end and passing the real service as an object. So now if we run this code, as you can see, we're calling the backend service through the interface iData service. Now if we swap that with the mock services, our program will still be good. So we want to test for mock data, which is what we have actually implemented here. So now that you have seen the front end relies on an abstraction iData service instead of a specific backend, we inject the dependency into the front end component. This way we can easily swap out the backend from the mock during the testing and switch to another backend. By following the DIP, our code becomes flexible, so we can swap the dependencies without breaking the front end. And it's also testable with the mock data during testing, and also maintainable as well. So this is the magic of designing for abstractions. So, and that's the dependency inversion principle in action. If you find this helpful, don't forget to like, subscribe and hit the bell icon, and let me know on the comment section if you want more videos on the solid principles or Python coding tips or software development in general. Thanks for watching and happy coding. I will see you on the next one.